of their own. They definitely do today. All right, we're back in. Click on your name, they should come back. Yeah, I had to go out of presentation mode. I wanted to start today, this presentation, with a poll. So let's go ahead and shoot that poll out. We have an entire 8 people signed in today. That's one of our lower numbers ever. However, it should be a good discussion. So if you would take just a second and answer these poll questions. First one, does your organization, I can't even read it all, use silica in your operations, basically is what I was asking. I can't read the whole thing. Second one, what type of work does your organization do where you're using silica? Pretty simple questions. Everybody's in progress, except for one. One says, I'm not doing it. Give you just another few seconds to complete that. All right. So I'm going to go ahead and close the poll, and maybe I will. Button's not working. It's giving you time. All right. Doug's smiling. He's like, what is he doing? Just having some technical difficulties. So interesting.
I love that noise. Donk, donk.
Yeah, donk. That's a bad sound in our world. All right. So here are the results of the poll. Does your organization use silica? 37% say yes, 37% say no, and 12% says I have no clue. and actually, that 12%, those are ones that you're in the right place. We want to help you understand what this stuff is. A lot of people don't understand what silica is and where it can be found. I was just talking to Doug about I'm doing some remodeling on a house, and over the weekend I was mixing up some drywall mud, and what was printed in big letters on the back of that, when I'm trying to find the instructions on how long this stuff takes to set up, it says, warning, this contains crystalline silica, and if you breathe this dust, it can be really bad for your health. Okay. And it's in a lot of products that we may not suspect are really bad for our health. The second question, what type of work does your organization do using silica? And I think you can actually add more than one on this one. I should have said that. One uses sandblasting, one concrete cutting and grinding, and one moving aggregate, and then other. I'm interested to know what those others are. So if you want to type that in the chat box when you get a chance there. I'm interested in what type of work that you're doing, because that can kind of help direct where we go with our discussion. So I threw the poll out there before I explained anything about silica, just to see, do people really understand what it is? And granted that you're here today, you probably know what silica is and what it might mean to you. Silica is a really common mineral. It is silicon dioxide, and it's the second most common substance on the earth, throughout the earth. It's everywhere. You say, well, how come we're not all dead if silica is so bad and it's so prevalent? The answer is it depends what form the silica is in, and whether we're able to breathe that material. There's silica in the sand on the beach, but that sand generally doesn't get up in the air unless my kids are throwing it, and then I yell at them, and it ends up being a bad day at the beach. But this material is all around us, and so the depends is part of it. You may have seen quartz and other minerals that contain silica, but it's really common. Here's some processes that can release silica, crystalline silica, to the air. Abrasive blasting, so sandblasting. Common thing, we go to the hardware store and buy some silica sand and use it to clean up parts. You may have an abrasive blast cabinet out in the shop that you use. A lot of cities that have water departments will sandblast the water meters. Sandblasting works really good on brass parts to clean those up and take off the corrosion. Okay. Sometimes it's cutting, like in this picture where we have a saw, an abrasive saw, cutting sidewalks, cutting concrete in one way or another. Grinding is another really common one. And here's one that people might not consider, and that would be moving aggregate. So a lot of our counties move a lot of aggregate. They're hauling rock, whether it be road base or sand or whatever that material may be, from one place to another. Sometimes they have gravel pits, and they'll have a crushing operation or a sorting, sizing operation. And each one of these processes, whether it's just picking it up with a loader or running it through the crusher, they all produce dust. And that can expose our people to crystalline silica. Sometimes it's cleaning. I'm going to use compressed air to clean up a workstation. All of these things can put that stuff up in the air, and it can be really bad for us. So how does this all play out? I'll just let this video play in the background as we watch. Here at a construction site, we've got concrete blocks, we've got cement powder or concrete powder in there. We've got guys cutting, sometimes even just shoveling, grinding brick, taking mortar out. This stuff gets up into the air, and we breathe it into our lungs. We'll follow this silica into this guy's lungs. If the silica is respirable, if it's in a small enough particle size, it can get into the deepest reaches of our lungs. And once it gets to that really deep part of our lungs, it implants. It hits the surface of our lungs. And then inside of there, we've got a little cleaning crew. These are called macrophages or white blood cells. And they cruise around the surface of our lungs looking for debris to clean those out, whether it be bacteria or something else. Their job is to gobble up this stuff and get rid of it. So it keeps our lungs clean and we avoid having infections, et cetera, et cetera. Once they're full of this stuff, they get absorbed in the linings of the lungs, and then the silica starts doing its damage. And over time, this is a progressive disease that you've got this stuff in your lungs, you'll always have it in your lungs. And if you get enough, it will kill you. So over time, it produces some severe effects. You may not, you go to work in this world, you don't understand that you're being overexposed. And over 5 or 10 years, or maybe even more, we're breathing this stuff into our lungs, and then the effects start happening. And unfortunately, thousands of people have died from silicosis and other related diseases that come from silica. This is serious business. It's not just dust. Oops, I hit the button twice. Sorry. And that's why. And that's why OSHA has this sign out there. Silica is not just dust. This is bad stuff. Produces things. Silicosis is a lung disease that is progressive. Certain kinds of cancer, lung cancer, are related with silica exposure. Most people don't last more than 5 years once they're diagnosed with lung cancer. This is a very lethal disease. This stuff can even affect our kidneys, our immune system, or make us more susceptible to certain diseases, tuberculosis and other respiratory diseases. And like I said, it can take either months. If I have an extreme exposure to crystalline silica, it can it can cause effects in a short amount of time, from months, or it may even take decades in an acute or in a chronic exposure, something that takes time. And that's kind of the scary thing about this, is we're getting doses of this and we don't realize that it's causing the effects that it can. Over time, we'll start to have a cough, shortness of breath, we may be really tired, cough up blood. Those types of things could be indicators that silicosis is happening. Oh, and I skipped one important thing. We were talking about silica. There are two types, or there are actually multiple types of silica, but two general types that determine whether the silica is going to affect us or not. There's crystalline silica and amorphous silica. Amorphous is stuff, you think of crystals, and we showed you that picture of a quartz crystal. It's pointy, and it's a certain crystalline structure. Whereas amorphous silica, if you look in products that you buy, will have a silica gel type material that's in a little packet that says "Do not eat." I buy a new camera, and there's this little white packet in there that has some little rocks in it, and it says "Do not eat." I always thought that was strange. They didn't want us to eat that, but I'm sure there's a story why that's on there. That's an amorphous type silica that is not going to be as hazardous to our system. Okay. So the difference is it crystalline, and can it get up into the air where I can breathe it? All right. So silica is deadly, and it is all around us. So let's ask a question on this. If I can't see this material in the air, is it still deadly to me? The answer is yes. It's that dust that we can't see very well that it's even more deadly to us than the big heavy clouds of big chunks of dust. You may do a task where you go out and you're sweeping up the shop, or maybe even tilling the garden or mowing the lawn, and you get done with that task and go to the restroom and blow your nose, and you look at the tissue and go, ooh, that's not good. But in truth, that's actually your body telling you that, or your body's doing its job. It's taking those big chunks out. Now, respirable dust doesn't get captured by our nose or our respiratory system, the mucus and hairs and all the things that are in our respiratory system designed to capture those particles and keep those out of the deep reaches of our lungs. Respirable stuff can get to the really deep reaches. So what is respirable? There's inhalable and there's respirable, and it's really particle size. If you're under 100 microns, which is a little bigger than a human hair diameter, that's inhalable. Smaller than that is inhalable. That means I can actually take it into my mouth and nose, but that doesn't necessarily mean that it's going to get to my lungs. Respirable dust is, if you watch the air quality reports, they talk about PM10 or PM2.5, but PM10, 10 microns or smaller, is that level where those particles are really respirable. That's where we're going to have those serious health effects, because it gets to the deep reaches of our lungs. Okay. All right. So now we know what the risks are dealing with silica. Let's talk a little bit about regulation. One of the reasons why we're giving this presentation is because OSHA updated their silica standard, particularly the construction standard, had some major changes, but they also updated the general industry standard a couple of years ago, and it's been through various stages. The change in presidential administration kind of pushed some of these things back. There was some litigation and some other challenges to this change, but this standard is in place now. What it did is it cut the construction standard, the exposure limit, the permissible exposure limit for silica, by 5 times. It's 1/5 of what the permissible exposure limit was before, and it makes it really hard to comply. All right, so there's a lot of dates on here. September 2017, June 23rd, 2018, General Industry Standard went into place. There's been some stuff to push that back as well. The most important line on here is UOSH, Utah OSHA. The federal standard's in place, but Utah has primacy. They run their own programs, and they're still reviewing the rulemaking on this. So it has not taken effect in Utah yet. It most likely will, from what I understand from Utah OSHA, it most likely will be adopted in the fall of this year. So we have a little bit of time, but we really need to dive in on this because portions of this standard can be really expensive and hard to implement. So we need to look at it and make some plans right now. So here's some of the major changes in the standard. It required a written exposure control plan, and that means a written program. I've got to write a policy, put one of those, and have one of those available, and make it available to the workers as well. Requires in the construction standard to have a competent person. That means somebody in your organization needs to be designated as the competent person for Silica. This is somebody that has knowledge and authority to be able to implement the right controls to protect people from Silica. The PEL, it established the lower PEL and action levels where we have to put all of this stuff in place. And also engineering controls, administrative controls, medical monitoring, housekeeping, and record keeping. We'll go through each one of these, but this is a major change to this standard. So like I said, the permissible exposure limit, or PEL, that's the limit where an employer can expose somebody, hopefully not intentionally, but as part of their work, they can be exposed to Silica at 50 micrograms per cubic meter, 8 hours a day, 40 hours a week for a working lifetime. That is the legal limit. Above that, you're going to be cited for exceeding their exposure limit. It established an action level. If your employees are exposed at 25 micrograms per cubic meter, then they have to be in a program. And like we talked, there's medical monitoring and a written program in place. These numbers are way lower than they were before the change in this standard. All right, so you say, well, what the heck does 50 micrograms per cubic meter mean? In my world, how does that compute? How do I know if I'm overexposed? And here's just a little indication. In this picture, I believe that's a dime, and just a little bit of crystalline silica there. If you took that amount of crystalline silica in a respirable size and got it up in the air in a room 10 by 10 by 7 feet tall, that would be 50 micrograms per cubic meter. This is a really, really small permissible exposure limit. And so how easy is it if I crank up a cutoff saw or a grinder on concrete to reach this level? It's really, really easy to be overexposed, and it's easy to put people in danger of having lung disease from it. So many of us are going to be affected by this standard, and so we have to plan. And you say, well, do I have to go out and do sampling? Do I have to pay somebody to come out and look at this? And of course, I say, do I have to go and do sampling for 500 members of the trust? The answer is no. You don't have to sample for this. OSHA gives us two options. One is to do sampling, to go out and take one of these things. It's called a cyclone, and what it does is it parts out the respirable dust from the non-respirable, and you throw away the non-respirable, and the respirable dust is collected on a filter. And we send it into a lab, and we can get a number and even parse out what types of silica are there. Is it quartz? Is it cristobalite? All these different types of silica. and then make a decision from there on our controls. That's one option. But most people are going to follow process knowledge and table 1. They're going to say, our only exposure to this is we have a rotary saw that we use to cut concrete when we're changing out a curb, or we're doing some utility work, cutting into a concrete street, or something like that. Or we do grinding on manholes to level things out. Whatever your task is, this is what we're doing, and these are the tools that we use. Well, if it's one of this list, here's a big list, sorry. I know it's not good to have big, long lists of bullet points, but here they are. These are the list of operations that apply. This is what Table 1 in the OSHA standard is, and so things, stationary masonry saws. Okay, so a saw that I use that's not mobile, and I can cut block, or I can cut tile or something like that. Handheld power saws, so that cutoff saw that you can pick up and carry around and make a cut into concrete. These are some examples of those, crushing machines, all of these. So you want to look at your operations and say, am I using any of these? If you are, then they provide us an option. So let's take a look. Handheld power saws for cutting fiber cement board with a blade diameter of 8 inches or less. Okay, so a small handheld saw that we'd use on a construction site to cut cement board. Okay, fiber cement board. And it says in here what our engineering and work practice control methods are. So for tasks performed outdoors only, use saw equipped with commercially available dust collection system. All right, so what does this mean? It means if there's a commercially available system, even if it costs 10 times what just a saw itself costs, I got to use it. That's the requirement of the standard. And that's really what we're seeing in the industry is this equipment is really quite expensive. A grinder that would cost you $100, $150, maybe $600 if it meets this standard. And so you've got to be a little prepared for the sticker shock. But this is the requirement, and that's part of the reason why there was so much kickback from industry over this. Is it's really expensive. Okay. Operate and maintain tool in accordance with manufacturer's instructions to minimize dust emissions. So that means we got to look at the owner's manual, and if it says I've got to replace this thing when something is damaged or there's a certain measurement on it, I have to do it. If I have to provide a certain flow of air from my vacuum to it, I have to ensure that that's happening. Okay. And it says in here, dust collector must provide airflow recommended by the tool manufacturer or grader and have a filter with 99% or greater efficiency. I can't just go to the hardware store and buy any old shop vac and hook it up to my grinder or saw. I have to have one that is documented to provide a 99% efficiency. That's almost a HEPA or HEPA vac, high efficiency particulate air filter. That's 99.97%. They gave us a 0.97 leeway on there, and that's really because of performance. A HEPA vac is really tough to keep running if we're running a lot of dust through it because they plug up. And so we want to look at this. So we want to look at our systems and say, okay, I'm going to go buy a vac, a shop vac, wet, dry, whatever it is, and realize that that's going to cost us a significant amount of money more than just a standard shop vac. Okay, and then if we go over to the right-hand side of Table 1, it talks about required respiratory protection and minimum assigned protection factors. So for this task that we were talking about, there is no required respiratory protection as long as I'm following manufacturer specifications and I'm using the equipment as it's intended. But if we drop down to the next one, it's for walk-behind saws. If I'm using this indoors, then I have to provide a respirator with an assigned protection factor of 10. And you say, what does an APF stand for? Whoops, I got that slide out of order. All right, I'm just going to explain it. An assigned protection factor of 10 means that it will protect you to 10 times the permissible exposure limit. And depending on the type of respirator, a half mask will give you more protection than give you less protection than a full face piece. A dust mask, an N100, or you're familiar with the N95 dust mask, will provide a lot less protection, and we're not going to get enough to meet that APF of 10. And so we have to select that respirator based on that. Okay, part of this standard is to designate a competent person. We talked about that already, that person needs to be knowledgeable about how to identify what contains silica and what the hazards are, and they have to be authorized and have the authority to take action to ensure that we have the appropriate personal protective equipment, and more importantly, the appropriate engineering controls. If that means they say we've got to bring in a different type of grinder or saw, or install water, so we're doing this with wet methods. That's the competent person's responsibility, and everybody that's affected by this standard needs to designate a competent person. All this dust talk's making me choke up a little bit here. All right, so protecting workers. If we can eliminate exposures, that's the best. Beyond that, we will try to engineer those out or control those through engineers. We can also use engineering controls and personal protective equipment, but it really comes in that order. Personal protective equipment should always be the last line of defense for us. All right, so eliminating exposures. If I go out and I find one of your shops has an abrasive blast cabinet, a sandblasting cabinet, I'll look at the cabinet and see if you're using a crystalline silica in that operation. If you are, I always give the recommendation: get that stuff out of here, clean it out, get rid of it, and let's use an alternative. There are other things that you can use for abrasive blasting that work just as well, and they won't kill you. So things like almond shell, coconut shell, aluminum oxide, there are a lot of abrasives that we can use in there that they may cost a little bit more, but they don't make you die. And so if we can eliminate the material, let's eliminate silica from the process. Okay. And just a thought on these. Sometimes we'll do a onesie-twosie job here or there. And hey, we've got that old saw out in the shop there. We can do this. My recommendation is, if you can't do it right, contract it. Get a contractor to come in and do that task. All right. I'm hoping you're able to hear me. Looked like we had a low bandwidth come through. So engineering controls. We want to use wet methods when appropriate and applicable. If I can wet down a material, its chances of it getting up in the air go way down. And so you think about a tile saw, and it's constantly pouring water on there. Of course, part of that's because you get a better cut, you get a better finished product with a wet cut. But a major part of that is it stops the dust from coming out. So use a wet method or a vacuum. And you say, which do I use? My answer is, go back to table 1 and look at what the requirements are, because that's really what you're going to be judged by. These have all been tested for their effectiveness. And so if it says it's okay to use a HEPA vac, it's okay to use that vac. All right. So engineering controls. Some of these controls are following manufacturer specifications for the amount of water, the flow of air that comes out. We follow those things. The other ones are follow the OSHA fact sheets, and these are easy to download on the OSHA website. Go to OSHA.gov. Up in the top right-hand corner, there's an A to Z index. Click on that, and then scroll down to Silica. Click on it, and over to the side that has these fact sheets. And you can go for each one of these, download it, and make sure you're complying. All right. Administrative controls. This is outside of an engineering control like water or vacuum or something like that. An administrative control could be maybe we don't let anybody in to where this stuff is. We've got a sealed off area and they can't get there. Sometimes an administrative control is I keep my operator away from the stuff. And that could be a excavator operator out tearing down, or maybe jackhammering with the hammer on the excavator. If they keep their door closed and their ventilation is appropriate, of course we've got to make sure the filters are in place and all of that. I limit my exposure by putting the operator out of the direct environment. Sometimes things can be as simple as working upwind from the process that's causing the dust. I learned this early on in my life when I was working out on the farm. When we were cutting grain or baling hay or whatever, I always wanted to be upwind because I didn't want that itchy dust getting down my neck. And so I'd try to come up with ways that I could stay upwind when doing that. And occasionally my dad got mad at me because I'd end up driving to the other end of the field and starting over again. So I was driving so the wind would take the dust away from me because I didn't like being itchy. Medical monitoring is also a part of our controls, and that is something that we're obligated to provide if our employees are covered by this standard, and that's to keep track of their health, so we don't get surprised by somebody having a silica-related illness. All right, personal protective equipment, like I said, is the last line of defense. This is something that when all else fails, we can use PPE, but we don't want to have this as our only line of defense. That's what we used to do. Well, it's dusty out there, throw a mask on, and that's not appropriate. We want to do our engineering controls and administrative controls first. But to wear a respirator, you need to be qualified. The respirator needs to be appropriate for the exposure. You use the wrong respirator for the job, and it's not going to protect you. It might be worse than not doing it at all. And of course, medical monitoring. So you need to be medically qualified to wear a respirator. Now, just a little sideline on this. I'm not going to go through all of the respiratory protection standard here. I've got another webinar in the loss prevention webinar series that you can go in and watch that to get all of the minute details. But we'll give you a brief overview of this so you know what you're facing if we're putting people in respirators. All right. So we need to train our employees on silica, its dangers, when it's appropriate to use respiratory protection, how to use it, what inappropriate use is, and how to care for it, when to dispose of it. All of those things need to be trained to the employees. We want to select the appropriate respirator for the job. Sometimes the covering matters. This is a helmet for an abrasive blast, where you'll go inside of an abrasive blast chamber. And this is pretty much designed to protect your face from being sandblasted off, at the same time providing safe air for that. They need to be NIOSH certified, and as far as filters that we're putting on this, they need to be certified up to a 100 level. That's the HEPA 99.97% high efficiency particulate air filter. That's the appropriate filter for this. And you've probably heard of an N95 respirator. That means it takes out 95% of the particulates above a certain particulate size. 99 takes out 99%, and 100 is that HEPA filter takes out 99.97%. The N, P, and R on these ratings, so if it's an N95, that means it'll take out 95% of the bad stuff, and I'm not exposed to oil in the atmosphere. Some workplaces you'll have compressed air being used, and there's some oil in that, or other operations that put oil. Those can affect certain types of filters. And so if I've got oil in the atmosphere, I would be using a P100 for silica. Okay, and you'll notice that these are that nice, pretty magenta color, so you can always identify that filter as being the appropriate one for particulates. Okay, the assigned protection factor, we talked about this already. What is the, how much can I be exposed to? So a half mask. Go back up. Didn't I? Oh, I thought I had a picture there. I did not. A half mask, one that covers just my mouth and nose, will protect you up to an assigned protection factor of 10. If I go to a full face, covers my eyes and the rest of my face is like the half mask, I could go up to 50 times. If I look at that quarter mask, I'm down to 5. We don't even have like an N95 respirator on this. So, all right. And so we go back to table 1. Remember that. Here's an assigned protection factor. On this one, handheld grinders for mortar removal, or tuck pointing, it's called. If you're working less than 4 hours per shift, then it's allowable to use an assigned protection factor of 10. But if I'm working more than that, if I work a full 8-hour shift, I've got to go to an assigned protection factor of at least 25. And so that would put me up into a full face respirator or a powered air purifying respirator. All right. So medical evaluations required prior to your fit test, prior to using your respirator. Anybody that's required to use a respirator more than 30 days in a year is required to have this. They need to be performed by a PLHCP. You say, what the heck's that? And that's a physician or licensed healthcare practitioner. That's a doctor or a nurse or somebody that is licensed certified to be able to evaluate somebody's respiratory health and whether they can safely wear a respirator. They need to fill out a medical questionnaire, and it's multiple pages. If you send somebody for one of these medical qualifications, you're not going to get a list back of what all their problems are or why they can't wear a respirator. You're just going to get a determination. This person may or may not wear a respirator, and that makes it pretty easy. On Silica, we also have the medical monitoring. It may involve a chest X-ray, particularly an initial baseline, so they can see where they're at, or if they have an exposure incident, they can see where they're coming from. All right, I covered all of that. Fit testing. Before you use a respirator, you need to ensure that it fits. The weakest link in using a respirator is the seal between the respirator and your face. And so we want to verify that that's happening. Doug's headed down south today, and he's going to do some respirator fit testing for one of our members there that had an OSHA inspection and needs to ensure that everybody's fit tested correctly. So how do we do this? There's a few different methods. And it depends on what type of respirator you're using. If you have questions about fit testing, please talk to me about this. It can be a simple thing. This one, they're probably doing a banana oil or a saccharin type test. I like the irritant smoke because you can't fake it. It's something when you breathe that stuff, it makes you cough. Not really hazardous for you, but it causes your respiratory system to react, and you just involuntarily cough. It's called stannous chloride or tin chloride. But we want to make sure this person can pass the fit test. Here's a guy failing a fit test. He says, "Whoa." Now, if he can't pass, we have him redon that respirator and we check him again. we may need to provide a different respirator, or sometimes people just can't get a good fit. They've got something with the size or shape of their face where they cannot get a good fit, and we can't have them wearing a respirator. Each time before we use a respirator, we're going to do a positive and negative pressure fit check. That means that we're going to test by closing off the inhalation and exhalation valve, and take a breath or breathe out and see if it puffs up. If I've got any leaks, I don't have a good fit. So this is something we do every time before we wear our respirator. Okay. I can't wear glasses when I'm wearing a respirator unless I've got some cut that were designed to fit inside of that respirator for a full face. We can't have anything interfering with the sealing surface of the respirator. So facial hair is out. If you're wearing a respirator, you can have a mustache to the corner of the mouth, and that's it. When you're using respirators, we want to keep them clean. If you have to take the respirator off, get out of the exposure area. Make sure you wash yourself, wash your face, your hands, and all those things, and clean the respirator up so we don't inadvertently dose ourselves with whatever the bad stuff, whether it's silica or whatever it is. All right, back to silica. The standard requires some housekeeping changes, and that means if we're dealing with silica, we can't do any dry sweeping. What does that mean? We'll do wet sweeping, and that's going to change our process significantly. No dry brushing. So if I've got a process where I've got silica around, I can't just take a brush and sweep that off. I got to use a wet method, and no using compressed air to clean things as well. We're required under the standard to do a program evaluation each year to determine, is the program working? Are we reducing exposures? Are we keeping those in control? Are we following our procedures and also reviewing medical results? Are we okay? Record keeping is just like every other OSHA standard is a major part of this, and so you want to keep all of these records on site. All right. So silica is a big deal. If you're working in one of these operations where people have where you're cutting, grinding, concrete, other types of materials, aggregate hauling, crushing, you need to look at this closely and determine, am I exposed? Are we covered by this standard? And then make some determinations at that point. Because of the exposure limit reduction, a lot of you out there may be out of compliance at this point. We're here to help. We're happy to help out wherever we can to help guide you in this and evaluate your processes and your equipment. Too much dust talk. Anyway, we're here and we're happy to help with all of this. Just let us know. Give me a call, and I'm happy to walk through the standard and your processes with you. Focus on those engineering controls. Download those tables, the guidance sheets from the OSHA standard, and they'll tell you exactly what you need to do. It makes it far easier to comply, because I can just say, hey, if I'm using this type of equipment and I'm using it properly, I'm in compliance. I don't have to go out and sample. I don't have to worry about all of those things. As long as the equipment's in good shape and I'm using it right, you're meeting the standard if you've got the paperwork in place as well. Don't just go, oh, this is too much, this is over the top, and not do anything. That's what we see sometimes when these standards get complicated and challenging, is people throw their hands in the air and say, oh, can't do it. Let's handle this and work hard on keeping people safe, because at the end of the day, that's what it's all about. We can comply with OSHA, that's great. We don't like getting citations and all of that, but the reality is we want to keep people safe, and we never want to have somebody die from doing their task, doing the work they have. Let's keep the mantra, not on my watch. Nobody dies on my watch, and and take it really seriously. All right, that's what I've got. I haven't seen any questions come in yet. You can type those into the chat box or the Q&A box, and I'd be happy to answer those. Doug, did I miss anything?
Jason, how could you have missed anything?
Well, because both of us got up way earlier than we were supposed to this morning. So. It was an early morning in the loss prevention world, so I may have missed something and not had it as clear. If you have questions, please give me a call, send me an email. We're happy to help out wherever we can. I don't see any questions, so you must have all got it. All right. Thanks, folks. Have a safe day.